Now that we know what variables are, we can use them to make our really first game. We already unzipped code.zip once in a folder called our first game, but it wasn't really a game, it was just an ugly picture. Let's see if today we can do a real game. I'm extracting all the files to a folder called Jetpack Joyride. Have you heard of such a game already? Jetpack Joyride is a game in which the player is always on the same X, but he can change its Y by jumping or using his jetpack so that he can avoid some enemies, some obstacles. You can see that there are also different extras, but we will only make the main gameplay in which we can jump when we press a key and fall when we don't. Well, let's see if it's funny in our version 2. This is the normal game.js that each time we are going to start with, and I'm about to show you how to use variables in programming on computers, not programming in real life. Well, in our game.js file there are already two variables created. On this line of code we are saying to the computer, create some space in the RAM memory where you will keep a number used only by my source code. Only my commands can change this value, and only my code can use this variable. So on this line I have created two variables. This one is called my X and this one is called my Y, and both of them start with initial value of 0. This is the first line that I'm going to teach you today. The first line of code for today is creating a variable. You can create a lot of variables on a single line of code. Like, for example, you can create a variable called ammo left. If you are going to shoot something and it can deplete, then you probably need a variable keeping how much ammo do you have left. We are not going to make a violent game yet. So I don't need ammo left just now. Instead, I'm going to teach you the second line of code for today, and probably we can finish this lesson so soon. Not at all. When I teach you just 2 lines of code today, you will be able to make really crazy and really different games. And the thing that we are going to create, actually the thing that you are going to create, is pretty similar to Jetpack Joyride. You will only need variables, and not only creating them, but also changing their value. There is also such line in our code that we can change the values of my X and my Y. Those lines that change the value of a variable always have equation sign, just like this line, and always in the left of this equation sign there is a single variable. This is the variable that will change its value. My X will change its value on this line. But what my x new value will be? Well, this is a computer's problem. The computer should evaluate the equation that you write on the right side of the equals sign, and there is a pretty scary formula here. I don't want you to understand what it evaluates, especially if you are a small child, then you can be really scared by all those additions, subtractions, and brackets. The round brackets can be used in a formula so that something is evaluated before the other stuff. Well, this is good, but what is this arithmetic sign? Well, this is division, and it doesn't look in the same way that it looks in maths. There is another sign that looks a little different than how it looks in math classes. So I'm going to write all the arithmetic signs that I want you to know from now on. Plus and minus are the same, but this is multiplication and this is division. And as I told you, we can also use round brackets. You can write those specific signs by pressing Shift. For example, Shift and 8 makes multiplication, and Shift and 9 and 0 are the round brackets we need to make some evaluation before the others. You don't need to press Shift for plus, minus, or dividing. So I don't think you want to write such a scary formulas. You can, but I doubt you want. So instead I'm going to write totally different formula. What do you think about this formula? Is it scary? Do you know the answer? Oh, dude, I have no idea what 3 plus 5 is. So I can check how my program behaves now. I will press Start HTML and I will see that the blue rectangle is now not chasing the mouse. Actually, it is chasing it, just like before, but only in Y direction. The downness of the mouse and the square are the same, or are getting the same really fast. But they are totally on a different X, they are in a totally different column. This is because I have written in my code that my X will always be 8. Oops, I just admitted that I know what 3 plus 5 is. Yeah, it probably is 8. And you can actually see that in this tiny space here, left of our blue square, we can fit only 8 white dots. Only 8 white pixels. And we can change this, of course. I can write a little bit bigger number here. And when I refresh, I will see that my blue square is a little bit to the right. This is pretty strange because why changing a variable could move a square? We learned in our previous lesson that squares and rectangles are drawn because of context point few rect lines like this one. And we learned that we always should write 4 numbers in the round brackets of context.fillRect. In this context.fillRect there are no 4 numbers, there are 2 variables and 2 numbers. So what is going on is that the computer is looking for the my x value and my y value, and it uses those values as x and y for the rectangle to be drawn. I can write really different formulas, and there will be really different behaviors of the blue square. For example, if I write 100 for y, this is also a formula, and it will always be 100 because it's really simple formula that will always have the same solution. And if I save and refresh now, I can see that no matter what I do, the blue square is always on coordinates 9 and 100. 9 pixels to the right of the left side of the visible canvas, and 100 pixels down from the top side of the canvas. I can also write one more 0, and then our blue square will be totally outside of the visible field, outside of the visible canvas. I better not do this now. I can write more stupid formulas with the same result always, but I prefer to go back to more interesting formulas. We still don't understand what this complicated formula does, but I can use its result, my y, in a simple formula for my x. For example, I can use the result of my y plus 1. And let's see what's going on now. It looks like I don't change the position of the square with my mouse moving to the left or right. But let's see what is going on when I move the mouse down or up. This is strange. Look how strangely the square behaves. The thing that is going on now is that my y is the same as the mouse y. This strange, scary formula is making my y really similar to the y coordinate of the mouse. And on the next update, my x is getting almost the same value. I can write kind of different value and we will see some change. Now the square is also again going in diagonal direction, but it starts from 100 pixels right of the beginning of the canvas. I can also write much different formula. For example, multiplying my y to 2, and now my square is changing its x really fast and its y is changing half this speed depending on the y of the mouse. I can write also a different formula. For example, I can multiply by 2000. Let's see what is going on now. Whoops. Whoop, whoop, whoop. I don't understand what is going on now. And I can go nuts and scared or crazy, or I already am, or I can try to understand what is going on with my x and my y. I can do this by using console log and not writing quotes in the round brackets of console log. When I want to see a value of a variable, I need to write its name without quotes. So I will write my x and my y, and let's see what their values are. I will press F12, and now I can see that most of the time the value for my x is pretty huge. This number is much bigger than the size of our visible canvas, and I can go even much more much more to the right, while my y is still a normal value. It's the second number to be logged. The first value to be logged is huge, not a good value, and this is a normal result from multiplication by 2000. It's not a good idea to multiply a coordinate by 2000 because it grows really fast, and only in small cases you can see this square sometimes. So I will remove this multiplication, and also I will write here our oldest formula, 3 plus 5, to see how are the coordinates now. Well, they're pretty boring because always the x is 8. The thing that I did logging the coordinates or any other variables that I can use for anything is pretty important tactic when you have a problem that you don't understand the cause of. I didn't know what was my mistake in the code, but I wasn't scared. Instead, I started to investigate my problem. I created console logs, and now I can see that my x was huge. I changed it, I fixed it, and now everything is going better. The bugs that you need to investigate with console logs are the harder to fix. I prefer bugs when our application isn't starting at all. For example, if I miss those equals sign, I will have a different mistake and my game will not start at all. You can see that I have an error in red, and now I know I have to fix something, and even I can see on which line is my mistake. Sometimes the mistake set here are pretty good and pretty direct to your bug, but sometimes the computer is confused what have you meant, and he's showing you a line that is perfectly fine and far away from your mistake. So don't be really fast to fix this error on the line that is set. Sometimes you need to look for error on a different line. Today I am lucky. I will look on line 5, and of course I have a variable, a formula, but I don't have equal sign between them. When I enter it, let's see my application working. I am about to stop talking. It was a long talk, sorry if I was boring. I think I showed you something very interesting. And now I want you to think and perhaps write your own code. I want you to think of a formula for my y. It will be much simple formula than this one. It will be a formula evaluating such a value for my y that the blue square is going to fall. I want you to make the blue square fall like this, but not caring about the mouse. Whatever the mouse is doing, the blue square should be falling down. You can do this because, as you've seen, the code that we write in update function is executed really often. It's executed at least 30 times a second. So if we write correct line of code, it will be executed 30 times a second, and the eye of the gamer will trick him into thinking that the square is moving smoothly. Our blue square will actually be teleporting, for example, with 2 pixels per update. But when the updates are so often, this teleporting will look like smooth animation, and that's what I want to achieve with your formula. It is going to be really simple but pretty strange formula that I want you to write about the my y value. Good luck!